Get ready because the shipping industry is ripe for disruption. You're listening to Autonomous Ships Headquarters Podcast with your host, JP.
Everybody, welcome to Autonomous Ships Headquarters Podcast. The goal of this podcast is to introduce to you people and companies behind digital revolution that is transforming the shipping industry. I'm your host, Jure Pavlica, or more easily just JP, and today's guest is Dor Raviv. Dor is a co-founder and chief technology officer at Israeli startup company called Orca.ai. Throughout his whole life and career, he's connected with the maritime industry and sea on multiple levels, from sailing the world with his family over his naval military service to founding a cutting-edge maritime technology company. Dor's story is one of those in which innovative engineers with entrepreneurial DNA scratch their own itch and create an amazing company and product. Stay tuned and hear how two friends started a company, how they raised capital, what product did they put on the market, and much more. So without further ado, meet Dor Raviv. Hi Dor, welcome to the show.
Hi Yura, it's a pleasure to be here.
Yeah, let's start with what are you doing and how you came up here where you are.
All right, so first of all, it's a pleasure for me to introduce myself and Orca.ai. As a big podcast fan, it's also very exciting for me to be presenting first time ever for me on a podcast. So thank you for that, Yura.
Yeah, you're welcome.
So I came all the way from Israel, which is not that far from here, and I grew up in a maritime family. Both my parents are actually been traveling on their catamaran for the past 8 years.
All right.
They sailed from Israel through the Mediterranean, Atlantic Ocean, Panama Canal, and then Pacific Ocean, Samoa, Tonga, all the exotic islands. And it's not a trip, it's a way of life. And I grew up into this family.
Wow, so you have seawater in your veins.
Yes, when you look out in the marina and you see the tiny kids sailing the Optimists and lasers and 420s, I was like that.
All right, and do you still sail?
Yes, I try to sail almost every weekend. And of course, that drew me to serve as an officer in the Israeli Navy.
All right.
Yeah, where I sailed for 4.5 years. I started as a combat soldier on a patrol ship. And then I was accepted to be a teacher or a guide at the School for Maritime in the Israeli Navy, where I actually teach navigation.
So you started teaching navigation there. You also have a college education.
Yes.
What did you finish? And
so at the end of my mandatory service in the Israeli Navy, I actually was chose to lead one of the interesting projects called Unmanned Autonomous Ships. It was 10 years ago. It's small patrol ships that are unmanned. And I was the first technical project leader for that project. And that actually drew me to study engineering. I started learning electrical engineering. And I majored eventually in industrial engineering with emphasis on data science.
Sounds like very logical steps that you took.
Yeah.
How and when was the Orcaai founded in all of this? So I guess somewhere after your military engagement was over, somewhere there these ideas were born to bring maybe part of these military technologies to civil applications.
So it's a very interesting question. For me, founding Orca.ai was an idea in the making since I was 13 years old, which is 12 years ago. And I remember as a kid, 13 years old, sailing with my father, by the way, near Croatia, in the middle of the night, you see nothing in front of you. And I remember seeing some distant lights near the horizon. And I remember the sheer fear of, should I wake up my father or should I just continue head on to maneuver the ship with sails? And eventually I decided to wake up my dad. And you need to understand, my dad is a experienced mariner is very close to a captain. You don't wake him up for everything.
Yes,
unless you bring in tea and food. And
was it a proper reason to wake him up in the end?
So I woke him up, and he said that one of the best things that happened is that I woke him up because we had to change course. We were on collision course with a huge ship.
Wow.
So remembering that sheer fear is actually what led me to eventually found Orcaai.
Amazing.
Yeah.
So your spider senses were sharp.
Yes.
Excellent.
So actually after graduation from college, I started working in Israel in artificial intelligence companies, and I worked there for 5 years as a hands-on developer for deep learning applications.
All right. And so tell us now you told us how the idea behind Orca.ai came to fruition. So when did you guys incorporate, and what kind of prototype did you build to raise capital? How was those early beginnings rolled?
So Orca was founded by me and one of my best friends from the Israeli Navy. We actually know each other for the past 12 years. We served together in the school for maritime as instructors. And my partner Yarden is actually more of a business-oriented man. He founded his first company in 2014 in the automotive space. It's a marketplace for selecting the correct mechanic for your car.
All right.
And it was in 2014. And we met each other by chance at the street a couple of years later. And our initial drawn to each other was based on the fact that the shipping industry and shipping domain, maritime ecosystem is way behind what's happening in the automotive space.
True.
And we decided to just go for it. So I quit my job, he quit his. And last year we were able to raise capital for founding Orca.ai.
Amazing story. So it was a lot of risks taken by you and your co-founder.
Yes.
Right. So how did it play out? You guys now have a funded company and a product on the market, right?
Yes. So the interesting part is when you go to a venture capital and you say, I want to bring innovation to the maritime industry, they look at you and say, what is the maritime industry? what have been done there? And no one knows how to eat it.
Really?
Yes. So we figured out very quickly that raising capital from a venture capital with deep pockets is a great idea, but we have to have access to the market. We have to have some sort of a strategic partner.
You want some smart money.
You want some smart money, and you want some money that also works for you, not just getting money from people. And this is why we were able to actually, again, by chance, raise some capital from one of the biggest ship owners in Israel. And he provides us access to his fleet.
Okay.
And when you bring the combined power of venture capital with deep pockets and a strategic investor with domain know-how, then you can found a sustainable business. And this is how we founded Orca, on that basis, with deep respect to the industry.
Yeah. It's, again, a very smart and good strategic move to do such a thing. And of course, you can leverage then all of the fleet's capability to get all the data that you need for developing your product. So can you tell us more, what is the product that you guys are offering?
Of course. So when entering congested waterways, the existing sensors on board commercial ships are unfortunately not sufficient. Why not sufficient? Because the amount of processing has to be done by the captain and the crew when entering and exiting congested waterways is just enormous.
Like an information overload.
It's an information overload. I mean, the radar is noisy and you need to clean it. The AIS is not always there. Not everything in the world has AIS. You cannot rely on automatic acquisitions by the radar. It's not there. And eventually, at the end of the day, we all hold binoculars and just look out the window. And this is exactly what Orca and the Orca system is designed to do, is to take all this processing and provide a clean user interface that shows only the most important and crucial parts of the voyage, of the world state. So the captain can focus on other things, like talking with the port, talking with the pilot, and maybe filling out some papers. So this is actually increasing efficiency and from there increasing safety.
So it's a situational awareness system that aids decision-making process from the people on board.
I would say it's more than that, because we started with adding the visual layer. We always started with vision. So our product now holds high-resolution cameras and thermal cameras. All of that is in a case suitable for the harsh marine environment, designed to sustain at sea. And it provides a clear view of what's going on. It's like eyes on steroids. And when you understand that, we start with vision and we extrapolate everything we can from the camera, the imaging sensors, and then you request the radar, the AIS, or the other sensors, what is there, you can build a very coherent world state in real time and present only the most important information.
Interesting. So it's you fuse multiple different sensors. You mentioned normal cameras, infrared cameras, AIS, radar, anything else?
Gyro, yes, GPS, of course. We also hold a database of all the ports in the world and their respective location, all the ships in the world with their respective MMSI name, width, height. So we are able to add a new layer of not only sensing the world, but analyzing it correctly. So we can present interesting alerts like dangerous situations, bow crossing.
Yeah, that's what my next question. What kind of classes for detection do you have? So what can you detect, and how do you present this to humans?
So coming from the maritime industry by myself and deep understanding of how it works, we start with what you say call-reg compliant. We start with looking on the AIS classes, and they are actually mapped to the classes we use the vision for. So if you able to classify a tanker, class A, for example, it will be a class that a classifier will provide. And we try to correlate that with existing AIS data in order to perform a better fusion between the camera and the AIS.
Okay. So you display on the screen the position and the class of that object, whether that's a buoy or a vessel. What can you classify except vessels? I've seen on one of your videos rolling also that you can detect buoy. Can you also detect humans in the water or smaller vessels that don't have AIS transponders?
So yes, the idea here is that you want to be able to detect everything that's interesting. So we are able to classify and detect icebergs and buoys and nets and bridges and types of ships, fishing vessels, jet skis, whatever that's out there. It's being sent to a deep learning architecture for object classification. And we hope, because deep learning is kind of a black box, we hope the classification will be correct and we'll try to correlate that with other sensors. But the idea here is actually sensor redundancy. We cannot rely on the fact that we have AIS information or radar information. And sometimes you cannot even rely on the vision sensors, let's say in low visibility. So the idea here is to build an entire ecosystem of sensors that provide an accurate mapping of the world.
Great. So let's say you classify now an object correctly, you position it on the screen. You can also position it in like in world coordinate system. But does the mariner that is on board, does it has a distance from that object? What kind of, or maybe the trajectory of that object?
Yes. So the idea here is to extrapolate as much information from each sensor as possible. When talking about vision sensors, one of the challenges is, of course, distance estimation. And when talking with captains, and you go and ask a captain, hey there, captain, do you see that a car carrier over there? What is the distance to it? He can estimate it quite accurately. And this estimation is the basis of one of our deep learning architecture. It's a classical problem for deep learning, where you can learn from samples. So you have AIS and radar label for distance, and you have the frame or the image, And over time, you can converge eventually on the correct distance. And the next time you see a new object that doesn't have any of these sensors, you're able to predict distance quite accurately. So in our domain, as opposed to autonomous cars or drones, where you have long time to digest what's going on, you need to be able to predict far in advance. This method is suitable enough.
So you're leveraging this fact that marine environment is not that dynamic, as opposed to the, for example, in automotive industry. So I've seen your product here on a fair. I must say it looks very beautiful. It's very nicely designed, unlike a lot of maritime systems. So there is a nice curvature. Can you tell us how long does it take for you to install this system on board a vessel, and how do you integrate it in the rest of the ship systems?
So it's a great question. When working with vessels, with operating vessels and not ones that are being built or in shipyard or fixed, you have to come with a lot of respect to the operational efficiency of the ship. So this led us to go with the plug-and-play approach. So we pre-calibrate everything in the office. Our system is running out of the box. When you just open up the computer, it just starts working, just presenting. The system itself is very reliable. It's built with a microservices architecture for redundancy. And then it takes us less than 6 hours in the moment you say that you want us to retrofit your existing ship with the Orcaai until you have fully fledged capabilities of our system.
So what are the components? I've seen this white nice box. This is a module that you put outside with I think 6 cameras, three visual and 3 thermal. Is the processing done also in that box, or there is a separated computer somewhere?
So we thought about taking the distributed computing approach, and we decided not to go there yet. The reason is if something fails in the processing unit, we don't want the entire unit to fail. So, and by the way, thermal cameras, they cannot see through glass because glass doesn't transform temperature. So this actually made us go outside and design the case ourselves to be ready for marine use. And we stream all the information from the cameras using Ethernet cables into the bridge of the ship, where we have strong processing unit with GPU acceleration hardware, both for inference of deep learning and for streaming massive loads of data. And we also provide a touch screen for the captain. So it's very similar to things that the maritime industry is already used to. Like radar, like GPS, any other system that has its own like server box inside the bridge somewhere. You have a screen and you have like the sensor itself on the monkey island above the bridge. So it's something that for them it's easier to digest.
Yes, to understand, and also for the system integrators in the future that might do this work for you. Also, it's a well-known practice on how to do. So in the end, you have a set of sensors outside and a new screen on the bridge, right? This is
a new screen on the bridge, and of course integration with the existing sensors.
Yes.
And this is the main reason we provide the screen, and the main reason we provide all this kind of hardware architecture is the understanding that we cannot break and cannot teach the people on board the ship how to operate the things. We cannot educate them. They have their method of operation.
You need to conform.
You need to conform. You cannot come, as I see it, you cannot come with the iPads and say, hey, everybody, just navigate with the iPads, because they would just open up Netflix, take the iPad, steal them. It's not serious enough. It's a serious navigation tool. It needs to be held as one, and you have to work like that. You have to be able to present how and why your system made the actions in a very clear and simple way, without training, without explanations, without multiple tabs, without multiple screens. Something very, very intuitive.
Very interesting. How does the weather conditions affect your precision in reconstructing the surrounding of the vessel. I would say you can experience some severe conditions on sea, and how does your system cope with it? And also in the end, you can tell us what was the worst problem that was there to solve.
So it's an interesting question, and I think you can look at it in two parts. One part is, what is the desired outcome of the system? Do you require the system to be able to detect a half-floating container in the middle of the night at sea with, 3 nautical mile distance? Because it's not for that. It's more of providing extra security for the operations of the ship. Mm-hmm. And we are using the thermal cameras to actually penetrate through fog and haze and pitch black darkness. Mm-hmm. That's one part. The other part is the data part, the variation of data. Mm-hmm. So when you look on a specific area of the world and you are able to map it correctly, maybe that night will come a storm that will change entirely the entire visual state. Mm-hmm. You now have icebergs and snow all over the place. It's the same place, it looks completely different. Yeah. You still want to be able to generate the same context of where you are and what you are seeing outside. So the question here is the variation of data. Mm-hmm. And by labeling correctly fog and harsh weather conditions, the system can actually alert the crew on fog and severe weather. Mm-hmm. So we can detect waves and foggy weather, provide you the immediate value that says, hey, switch to thermal because you don't see anything outside.
All right. What is the business model behind? So do you only sell hardware, or is there like a subscription to this service? Like what is the pricing model behind your product?
So this is also a very interesting thing to see, some sort of a shift now that happens in the industry. No one wants to buy boxes anymore. Mm-hmm. Because boxes fail, and then you need to buy another one, and the margins are low. Everyone now wants to use more modern approach, mm-hmm. which really resembles a leasing model. Mm-hmm. They don't want the hardware. They want mm-hmm. the capabilities. They want the ability. So our business model is currently kind of a lease. You can mm-hmm. look of it on an annual subscription, okay. where we provide the system, we install, we do everything, and then we update the system all the time. Mm-hmm. Because the fleet is actually getting smarter because of the sharing of information between vessels. Mm-hmm. And we also introduce new capabilities all the time, more mm-hmm. alerts, maybe weather, and then maps, and then path planning. So mm-hmm. the future here is quite straightforward, and you can see how you want to pay for it. Mm-hmm. You want to pay less and get less capabilities, or more and more capabilities. Mm-hmm. Something very similar to software as a service kind mm-hmm. of model.
And the microservice architecture is the perfect building block that you can do such a thing. So
exactly.
That's amazing fusion of the best of all the worlds. All right, so it's a lease. Do you also, in this lease is also maintenance mm-hmm. of the thing, and the updates are over the air, I guess.
Yes, so all the updates are over the air. And interesting part about the updates is we use something called collective learning method, which means if one ship entered, let's say, a port in Japan, mm-hmm. and the other ships didn't, we actually label, collect, tag everything we need to know to understand correctly the Japanese port. Mm-hmm. And then we deploy the knowledge of how the port looks like and mm-hmm. what's going on over there to the entire fleet. Yeah. So when another ship in the Orca fleet actually arrives to the port, it already recognizes what's going on. So this is called collective learning, mm-hmm. and it's an approach taken a lot in the automotive space, mm-hmm. and we are the first ones to bring it into the maritime industry. And for that, we actually had to design a specific algorithm that takes advantage of the long digestion time you have at sea, mm-hmm. where actually 95% of the data is irrelevant for deep learning applications, mm-hmm. just plain sea and sky. And the 5% of entering congested waterways is the most interesting and prominent parts of the voyage.
So you need to prune your data sets, and if you can do it automatically, then you can save a lot. Because is it because of the oversampling you'll do with all of this, let's say, boring parts of the route?
Exactly. I mean, deep learning is a great technology, but it also has its own biases. And if you bias your entire system to, let's say, plain sea and sky, that's what the algorithm will learn is the world of itself. And this is not a desired solution. So our algorithm is cherry picking only the most important parts of the voyage, like changes in course and speed, and changes of other ships and how ships behaved.
Interesting. And this brings us just to one of the last questions. A lot of this data has been collected on board, and if you want to do this transfer learning, a lot of data needs to leave the vessel as well. So in this whole game of pushing data back and forth, who owns the data? Is the vessel operator, ship owner, or under your lease conditions you own the data? Can you just clarify a little bit for the listeners this because a lot of people are concerned about their data. So what's your approach on this privacy issue?
So let's talk a little bit about privacy and how it became a hot trend recently. Privacy, when talking about consumers, is pretty straightforward. But when talking about fleets of ships, we never know who the other ships are in terms of who's the captain, who's the crew, what they are carrying, all the sensitive information. We just know to localize the world, which is something that's usually public through AIS anyway. And that's why we are not required to comply with any regulation. And if so, the regulation is way behind in the maritime ecosystem about transfer of data. The second part here is we own the data for research and development purposes. And if one of our clients would love to get like a black box of something that led to an interesting incident, then for us it's a no-brainer just to provide this data for him. This data is, it's pretty normalized data without any privacy stuff.
And are there any open data sets available in the maritime arena? I know that, for example, for automotive industry, there is like Kitty data set. You have all kinds of labeled data sets. Is there something similar available in maritime? For research development and those sort of things.
So it's very interesting that you say that. As a startup company, of course, we started with off-the-shelf algorithms and public data sets. And very, very quickly we understood that, first of all, there is not sufficient data and the algorithms are not tuned for the maritime ecosystem. So you have some universities and research institutes, but they are all like very sparse data sets that were taken from shore to sea, poorly labeled, something that used for some students in their projects, not something that you can actually count and rely on when developing a product. So the first effort of the company was data collection. Prior to user interface, prior to object detection, prior to everything else. First, get the data. And that's the most challenging part and then you understand you need to build some platform to collect the data, to analyze the data, to label the data. So all this process is quite tedious, but now it's being done semi-automatically anyway with human supervision.
Great. What are the future plans for Orca.ai?
All right. So as a startup company, we need to raise more capital. And if we want to raise more capital, we need more paid pilot with more commercial ships and shipping companies and ship owners. And once we get to a place where we feel confident and product market fit is being done correctly, and we can generate traction and interest and actually provide value, which we are doing today, but fully understand our value proposition, then it's a good time to raise more capital and increase our capabilities and spreading out the word to more ships getting more data, being smarter and smarter, increasing the overall knowledge of the fleet. And technology side, of course, enhancing our alerting capabilities, path planning capabilities. So when the order comes and the world is switching to semi-autonomous world of shipping, we will be the market leaders, and it will be just a switch of a button and connect the autopilot to our system.
Great. Amazing and compelling vision of the future. And I see you guys solved a lot of issues already and are on a very good trajectory to executing your plan and becoming one of these leaders. So I wish you all the best, you personally as well as the Orcaai as a company. And maybe we can do a follow-up in some time to see where you guys are then. And just for the end, could you tell us where can people find more about Orca.ai?
Yes, of course. So first of all, we have our website, Orca.ai.io. You are more than welcome to visit there. We also have our LinkedIn page, Orcaai. And just search us on Google. You can see some press releases and interesting stuff. The maritime ecosystem is now booming with new ideas, new technologies, and new players. And I think I see a bright future for the maritime industry and the maritime ecosystem. And let's hope that the next time a 13-year-old kid sailing near Croatia, he'll have some sort of a system that could keep him safe.
Great. Amazing. Thanks a lot, Dor, for being a guest on our podcast.
It was a pleasure. Thank you.
And you made it till the end. Thanks for listening, and don't forget to follow us on Twitter. Our handle is @AutonomousShips. You will also find us on Spotify, YouTube, and LinkedIn. If you like the episode, the best thing to do is to share it with your friends and colleagues on social media. That's how we can grow the audience and continuously improve our work. Besides that, your feedback is always appreciated, so feel free to drop us a comment or an email. Thanks again, and until next time, my friends, take care. Hoi hoi!